today we are going to start there is a physics concept that I'm going to teach you, and that concept helps to solve you this numerical that you can see here. Okay, so let's first go into this concept, or what is concept, and just have a look on this question also. A bullet of mass 10 gram is horizontally fired with a velocity of 300 meter per second from pistol of mass 1 kg. What is the recoil velocity of the pistol? Now we need to find the recoil velocity. Before solving this question, there is a concept. Two things are there. Number one, that is that in this thing what we are going to cover, that first is third law of motion. Okay. Second thing we are going to cover about conservation of momentum. And in this conservation of momentum, we will also talk about two things: elastic and inelastic collisions. Elastic and inelastic collisions. Now, first we will start that this numerical is depends upon the concept of third law of motion. How? That a bullet, let us get this thing by help of a diagram, with the help of a diagram. Okay, so there is a, let us say it is a gun. Okay, this is for easy, this is your gun, and let us say this is your bullet. Okay, now when bullet is being shot from the gun, this bullet, the shooting of bullet is action, and whatever velocity that this gun moves away from the bullet, or this direction of bullet is this word, yani towards right side, and bullet, the gun vice versa is in the opposite side. Okay, now both are in opposite direction, so it is a reaction here. So action reaction, that is third law of motion. Okay, now in this action reaction, it comes under the conservation of momentum. Now what is conservation of momentum? Now conservation of momentum means initial momentum is equals to final momentum. Initial momentum is equals to final momentum. Okay, now what is initial momentum? Formula of momentum is equals to P equal to mv. Now let us assume some variables here, like mass of bullet is equals to mb, initial velocity of bullet, let us say ub, mass of gun mg, and velocity of gun will be vg. So initial momentum. Okay, now initial momentum will be okay, so mass of, one more thing, mass of gun mg, and initial velocity of gun is ug, and mass of gun mg, and final velocity of bullet, the final velocity of bullet is left. Okay, now mass of bullet, initial velocity of bullet, mass of gun, final velocity of gun, mass of gun, initial velocity of gun, mass of bullet, or final velocity of bullet. Okay, now initial momentum, initial momentum will include initial velocities of both gun and bullet. So mass of bullet, initial velocity of bullet, plus mass of gun and initial velocity of gun, equal to mass of bullet and final velocity of bullet. Correct? Then mass of gun and final velocity of gun. So this is the equation for initial and final momentum together, and this is called conservation of momentum. Okay, now initial momentum means when gun is not fired. Okay, when bullet is not fired or gun is not firing the bullet, at that point can I say ub is equals to ug is equals to 0, because there is no motion in both gun and bullet. That means left hand side becomes 0, totally 0. Now mass mb vb plus mg vg is there. Now we will use this equation to solve this numerical. Okay, let's have a look. Bullet of mass 10 gram. Okay, the mass of bullet is given mb. Mass of bullet is equals to 10 gram. Okay, then fired velocity, this is final velocity of bullet, remember 300 meter per second. Mass of gun is given 1 kg, okay, 1 kg, and we need to find velocity of gun, that means final velocity of gun. Put here 0 is equals to mb, mass of bullet. And now remember, mass here should be in kgs. One more small thing is there, so that means divide by 1000 into velocity of bullet is 300 meter per second plus mass of gun is 1 kg, it is good, so vg. Now when you solve it, and cancel, okay, 1 2 3, all three are cancelled, that means 0 is equals to 3 into vg. So velocity of gun will be minus 3 meter per second, remember. And by this minus sign shows that velocity of gun is opposite to velocity of bullet. Okay, so this is the first type of your numerical. Okay, now next numerical, let's try one more of this is also your NDA PYQ. This is also NDA PYQ, and this is also NDA PYQ. Okay, so just have a look on this numerical. A boy of mass 52 kg jumps with a horizontal velocity of 2 meter per second onto a stationary cart of mass 3 kg. The cart is fixed with frictionless wheels. Which one of the following would be the speed of the cart? Now, before going this question, we will be getting into two concepts. One is two concepts are there. One is elastic collision. One is inelastic collision. Now, what is elastic collision? In elastic collision, two bodies are there. Let us say mass of ma, a and b are two bodies, mass of mb, moving with a velocity of ua and ub. Now, when they collide a b, after collision, body mass mb a, then they will move with a different velocity va and vb, different final velocity, different initial velocity. Now in inelastic collision, what will happen? Two objects are there, definitely a and b, moving with initial velocity ua and ub. They collide with each other and ultimately they will move together with a common velocity a, b, and mass ma and mb. Here also mass ma and mb. So these are different between elastic and inelastic collision. Now remember, conservation of momentum is applicable in both elastic and inelastic collision, but conservation of kinetic energy is different in both of them. Conservation of kinetic energy is in elastic collision but not in inelastic collision. Okay, remember this thing. Now this question is of inelastic collision. How? A boy, imagine a boy is there, okay? A cart is there, stationary cart is there. Let us make this cart like this. Okay, he has a mass of 52 kg coming with a horizontal velocity of 2 meter per second. It is a stationary, that means this is the initial velocity of object A. Let us say object A. This is initial velocity of object B 0, and it jumps upon the cart. Now when he jumps, both of them stick together like this in the similar case and moving with a common velocity. We need to find that common velocity. Okay, mass of this cart is given, mb is given 3 kg. Okay, so let's solve this numerical, and it also be solved on the conservation of momentum. Okay, conservation of momentum, similar thing. Initial momentum is equals to final momentum. Now initial momentum, definitely mass of the object A, initial velocity of object A plus mass of object B plus into initial velocity of B, final velocity. Now it is an inelastic collision. Now it is ma plus mb together v, like this for inelastic collision. Okay, remember. Now ma and mass of the boy, that is 52, okay, into ua coming with a velocity of 2 meter, correct, mass should be in kgs. Now mb, that is 3 kg, but ub is 0 here, remember this thing. Now 52 plus 3 into v. Now 52 plus 3 into v, that means 52 in 104 is equals to 55 into v. Now divide 104 divided by 55, so that means it will be approximately equal to v is equals to 1 1.1 55, okay, 9 14 9 4 49.0 and 55, I guess 1. This option eliminated easily. Now try with 8. Okay, try with 8. It was a 40 44. Yeah, it is very close to it. We can go with 8. A is the correct answer. That means V is equal to 1.89 meter per second. I hope you understood this question. Okay, thank you very much. Bye.